What else do we have? Well, this has come aboard about 3 years, maybe 4 years now. It's the RFIDs, and the RFID switches called the SI-RF. There's again a family of these, and they're used basically again to monitor that doors or gates or any other safeguards are opened or closed. The nice thing about them is that they are very flexible in the fact that there's a 10 millimeter misalignment tolerance, which is much better than those mag switches. You now have a chance where vibration that could be attributed with the application, at least if it's just bouncing around within that 10 millimeters, you're not going to see any type of change of state. It's able to handle a lot of vibration, in other words. And it's IP69 rated, which is very good. But it does have different families of the RFID as far as the coding of the actuation next to the sensor. Some do not have to be taught whatsoever, and that's considered as low, meaning that you can take any actuator, it'll respond to the sensor as soon as it comes within proximity. Otherwise, the ones that are rated for high and unique, you do have to teach them by simply cycling power when they're together for 2 events. Power on, power off again. Now it's going to be taught to that actuator. The code that is coming from the sensor is going to be received from the actuator. The unique means that you cannot teach it more than once. If you lose or damage one of those parts, you got to replace the whole set. The high means that you can actually reteach it up to 12 times. So you can have, if you lose an actuator or damage it, you can grab another actuator and reteach it to that. So different levels for different tamper resistances that you might be looking for. Great thing about this is that you can cascade up to 32 of these sensors in a string, and all of those can be identified, knowing which position they hold. The great thing is when you take it into one of our safety controllers that have in-series diagnostics like the SC10 and the soon-to-be-released XS26, that is going to be able to know exactly all the information that it's going to be able to gather data-wise from every one of those inline switches, but also which one in order is the number 1, 2, 3, or 4, and that type of thing. A lot of diagnostics you can grab off of that. All right. There is actually another actuator choice. Works the same way, the same 10 millimeters flexibility. It happens to be slightly smaller with a lot more holes that can be used because its intent is that it perhaps is going to be on a very thin door where you may want to mount it on the edge of that door instead of on the side of the door. So it's smaller and has more through holes to be able to set that up for some smaller usages of doors. Actuation direction, very, very flexible, which is another great thing about the RFIDs. You can come at it in different angles, side by side, directly at each other, or coming down from a vertical distance, and once it lines up in front of it, it sets it off. So a lot of ways that you can set this up and run. This here is grabbed off of the RF data sheet. It's just showing all the different model numbers and where they kind of fit as far as the usage. For example, if all I had was a single door and all I wanted to do was monitor that one door with an RFID switch, you have families of model numbers here that are all represented by the single PNP, meaning that you cannot cascade it with some cabling to another one. It's just going to be a single PNP, single switch going to its own controller or gate monitoring module. The in-series diagnostics, well, I should say these are very typical. They're the same in the sense that you can have up to 32 of these in one string. And at the end of the line, all you're dealing with is 2 OSSD outputs. So it's very easy to accommodate on some of your controllers like an SC10 that doesn't have a whole lot of terminals. But these act the same way as far as being able to be connected like that. But the models that are from here on up are not going to have that in-series diagnostics where you can retrieve all the inside information like temperatures, the gap that you're holding, all types of things that are going to be able to be taken through the Ethernet and tracked if you wish. So same type of structure though. You have unique high and low coding. You have even models that are going to be automatic, meaning that as soon as you shut the door, everything's ready to go. Otherwise, there are manual model numbers on these things here so that if you shut the door, it's going to sit there and wait for a local reset to happen just for that door itself. And the reason for that might be you might have some of these RFID switches on doors that you can walk through. And if it's something you can walk through and be on the inside, you need to have a local reset so you return out of that area, shut the door, hit that reset. That's the reason why there is obviously some different variations of models here depending on if it's trip or latch. This is just showing those RFIDs in the structure of having multiple ones tied in the series and the different types of options as far as if it is a manual reset type of a model instead of a trip. Here is a connection that is made with this specific model number of a T connector where you can now bring in a reset signal to help that out. But that same type of connector can also accommodate normal trip type connectors where all I want to use this for perhaps is to get that auxiliary output. Maybe I'm taking that back to a PLC, but you can get an auxiliary output, a PNP signal on the black wire if you hook up a very common MQDC cable that we use for a lot of applications. What else could I use this for? If I happen to, and I'm kind of getting into the ISD thing here, but we're still talking about RFIDs at this point. Whenever you have as many as 20, 30, 32 of these in a string, you're going to start to lose a little bit of the power that's held at each one of these. So these are also can be a very nice place to boost up your 24 volts by simply bringing in 24 volts further down the line to accommodate the ones that are losing a little bit of power. You're already going to have power coming into the first ones. It's the ones at the end of that 32 RFID switch setup that's going to be a little bit low, and you want to be able to get that up where it's above 19 volts. A lot of stuff there on RFID we can talk about once we get into the controllers. But this here again, not only the RFID switches can you add into an ISD in-series diagnostic string, we now have a component that accommodates even all of these typical mechanical switches I've been showing you. If you've got two closed contacts within that switch, it can come into this ISD Connect. That's the name of this new component. And this ISD Connect is looking for those two contacts, and it might be a contact from each one of these through the splitter or coming directly from a switch, but a great way to accommodate anything and anybody's type of mechanical switches. Even if they don't have ISD technology, this is what gets you there by being able to tie that in to that string of 32. So great technology changes that are going on in the safety products, and that's about it, and we'll see you next time. Thanks.